Okay, now on the back side of the notes, it starts out with, how do you solve the quantity x minus 2 squared equals 25? Well, there's something that I consider the long way, which I think at this point in time, this is the way that you all would probably want to solve it. You all would probably automatically want to go ahead and get this in standard form. And there's nothing wrong with that, but it does take a little bit longer. So let me show you what I mean. You all know that x minus 2 squared means x minus 2 times x minus 2 equals 25. You also know that you have to multiply this out, use the distributive property, and you would get x squared minus 4x plus 4 equals 25. Then you would have to subtract 25 from both sides, and you would get x squared minus 4x minus 21 equals 0. Then you would finally factor it using the factors of 7 and 3. The 7 would have to be negative, and the 3 would have to be positive to make the negative 4 happen in the middle. Then you would finally use the zero product property to get both of your solutions. So x equals 7, x equals negative 3. Well, that is a lot of work, and there's nothing wrong with that, and I'm pretty confident you all know how to do that. But what if there is a genius way? What if there is a better way to solve this? So if you have x minus 2 squared equals 25, why not use math to your advantage? So over here, we followed a very logical set of rules, mathematical rules. Well, we can do the same thing over here. Notice how this is isolated by itself and 25 is by itself. Why can't we simply do the square root of this side equals the square root of this side? I did it to both sides. I did it to all of the pieces. What's great about this is that the square and the square root will undo each other, and simply x minus 2 drops out. And you know that square root of 25 has a positive and negative 5. Well, the rule is if you want to isolate x, you're going to move the 2 in front of your plus minus symbol. So I'm going to add the 2 over here. And then what that means is I have two different problems here. I have x equals 2 plus 5, and I have x equals 2 minus 5. So x equals 7 and x equals negative 3. Same exact answers, less work. So I call that the genius way. It's actually just using square roots and math and making your life a little bit easier. So let's look at number 7 and see if we can use the genius way to our advantage. So let's look at the first one here. We have 2 times x minus 2 squared equals 18. Well, let's try to isolate that square root, or the square here, so we can use square roots. So I divide this side by 2, I divide this side by 2, I get x minus 2 squared equals 9. That's a square. I can get rid of it by taking the square root of both sides. This and this undo each other. X minus 2 equals a plus minus 3. Move the negative 2 by adding it to the other side. I get 2 plus or minus 3. So x equals 2 plus 3 is 5. 2 minus 3 is negative 1. Therefore, we're finished that quick. So now let's slide over to box 8 and you try this one by yourself. It is 6 times x minus 4 squared equals 42. And let's leave our answer in exact form. What that means is you're going to leave it in square root form. So pause the video and try that one by yourself. Okay? So hopefully you divided each side by 6 and you got this expression. And I don't want you to be confused because 7 is not a perfect square like this one over here. You just leave it in exact form. So you take the square root of both sides. You have x minus 4 dropping out equals plus or minus square root of 7. Add the 4 to each side. Remember, you're going to keep it in front of the plus minus. So x equals a positive 4 plus or minus square root 7. So since we're going to leave it in exact form, we just leave it like that. Now, if it did say to use decimals, you would simply do this. You would say 4 plus the square root of 7. That's your first answer. And then you would simply say 4 minus the square root of 7, and that would be your answer. But I did say exact form, so we can just leave it there. Okay, now the next thing we're going to look at is the word problems. They're actually not that bad. Question 9 says you drop, it's a key word there, you drop a towel from a balcony 18 feet above your den onto a table that is 3 feet above the ground. How long is the towel in the air? Now, if you are dropping something, you do not have a velocity. And we will be going over this little formula here. So I'm going to give you the formula. And the reason why this is in this section is we are dropping the towel. We are not throwing the towel. Therefore, we do not have velocity. Now, here's how it sets up. The ground is 0. Negative 16t squared always stays there. And the towel starts at 18. So the 18 goes in for S. So now I have gave you the equation, except the towel does not go to the ground. It goes on a table that is 3 feet. So that actually needs to be a 3 right there. So if you look at what we have on our hands, we have an equation. We're solving for t, how long is the towel in the air, and I do not have a velocity. So now I can simply subtract the 18 from the 3, and I get a negative 15 equals a negative 16t squared. I divide by negative 16, and I get 15 over 16 equals t squared. So I square root both sides, and t is going to equal plus or minus square root of 15 over 4, because I can actually do the square root of 16. However, this is a real life situation. That does not mean hardly anything to me. And I also know I can't have negative time. So actually what we're going to do is we're going to go away from the exact answer here, and we are going to find the square root of 15 divided by 16. And I get 0.968, so if I round to the nearest hundredth, I get 0.97 seconds. And if you think about it, if you drop a towel from a balcony that's 18 feet onto a table that's 3 feet, it takes about a second because it does not take the towel very long to drop. Now, this formula here, we'll talk more about this formula and we'll label everything. So remember, the H is where the towel drops. Velocity was 0 because we dropped it, and it started at 18. Now, that's a vertical motion problem. Now let's slide over to number 10 and look at this problem. It says a square frame has a 2-inch border along 2 sides as shown in the diagram. The total area is 66 square inches. What is the side length of the unshaded region? So unshaded. We know this is 2. We know this is 2. What don't we know? Well, we know X would be there, and it says that it's a square, so I know an X could be there. Now, it told me that 66 is the area of the total figure. So 66 equals the total. So I know the area of a square is the same as L times W, but in our case, this is side times side. So the whole area is 66. The side of the square is x plus 2. The other side of the squared is x plus 2. So this is actually 66 equals x plus 2 squared. Well, remember, we don't have to go through that long process if I have an isolated square equal to a number. I can go ahead, square root both sides. That undoes each other, so it's x plus 2 equals a square root of 66, and a plus minus is in front of it. Now, this is looking a little backwards, so remember when I isolate x, I always want this number in front of the plus minus. So I'm going to subtract the 2, and it's going to go in front of the plus minus. Square root 66 equals x. Now, once again, I am in a real life situation, so this exact answer really doesn't make much sense. So I turn to my calculator and I type in -2 plus the square root of 66, and I get a positive answer of 6.12. And then the next answer is going to give me the negative answer. And once again, x cannot be negative inches. So we are going to go with x equals 6.12 inches. If I wanted to say an exact answer, I would say -2 plus the square root of 66. So that would be your exact answer there. Okay? Now, question 11. It is a simple problem. It just says find the radius of a circle with the area of 144 pi. Well, the first thing you would need to know is the area formula for a circle. So area equals pi r squared. So it says find the radius, we are looking for r, with an area of 144 pi. So we would substitute in 144 pi, in for the area, and we would say pi r squared. We would divide by pi, divide this side by pi. So I have 144 equals r squared. I would square root both sides. I would get a plus or minus 12 equals the radius. But if I have a circle with a radius and it's inches, I cannot have a negative 12-inch circle. So the radius in our case will be 12 inches. Okay? So if you notice all of the word problems, what they have in common, they all had in common, there's a t squared, there's an s squared, there's an r squared. So this is called the square root method. When you can actually isolate the variable with the square, you are missing the bx, or in this case, the vt. So what all can happen? Here is the recap of everything that can happen with square roots. If you have two solutions, then x squared is going to equal a positive number. Now that is when x squared is isolated. So you isolate and you get x squared equals 3, you are going to have two answers. If you have x squared equals 81, that's a positive number, you are going to have two answers. Okay, when are you going to get one solution? When x squared equals a 0. So it doesn't matter what's going to happen. If you get x squared equal to 0, it'll be one solution. So for example, x squared plus 2 equals 2. If you get the 2's together, you get x squared equals 0. Take the square root, you're only going to get a 0 for an answer. Now, when are you going to get no real solutions? So no solutions. It's when your x squared, when isolated, equals a negative number. So, for example, x squared plus 2 equals a negative 2. You subtract the 2, and you get x squared equals a negative 4. That cannot happen. Another example would be negative 3x squared equals 3. You divide by negative 3, x squared is now isolated. That cannot equal a negative 1. So this concludes the square root method.